Welcome back, guys. My name is Dr. AVITECH, and in this video, we're going to be solving these questions on gamma functions. Now, in the earlier video or previous video, we've talked about or have introduced this very topic. So we first have to know that this relates to the factorial. It relates to factorial. So first of all, let us solve this. From the first question, we're asked to integrate from 0 to infinity of t to the 7 e to negative t dt. As you can see, I said something earlier. I said there are much more convenient ways to solve some type of integrals. Example this. It's much more convenient to use the gamma function. So let us solve the first one. I'm going to be using red for this. So the integral from 0 to infinity. Now remember to always make your video to be full screen so you can see everything, and also increase the quality at which you're watching the video. Remember to hit the subscribe button and like this video. Also share it to your classmates. Now if I were to do this, okay, let's get into the video. E to negative t dt. And what I'm going to do is, if you look at this properly, this looks like a standard form or standard way of writing gamma function, where the power here is always x minus 1. The power there is always x minus 1. So what does this tell me? This tells me that this is actually the gamma of 8. Let me explain how it's the gamma of 8. Remember that gamma function says that the gamma of x plus 1 is equal to integral from 0 to infinity of t to the x e to negative t dt. That's the gamma function. Now, this also tells me that if I have a number here, 7, if 7 was here, that means what is here is actually 7 plus 1. That's the meaning. So that's how I got 8. As I got 8. If you're moving from this place, from the gamma part to the integral part, you minus 1. From the integral part to the gamma part, you add 1. So this will become, the gamma of 8 is 7 factorial. So most persons don't really stress themselves to write in terms of gamma. I inclusive, if I want to solve problems like this, I don't even write in terms of gamma. I just go ahead to say 7 factorial because I have 7 here. So 7 factorial. It's easy that way. But there are times where you need to write it like this. We're going to see that in future problems. So what's 7 factorial? That's 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's 5040. That's the answer for that very integral. As you can see, it's much more easy using gamma function. So number 2, the second problem. We're going to integrate from 0 to infinity of pi x cubed e to negative x dx. Now this is actually a simple problem. The only thing that might look tedious is the pi right here. But please take note that pi is a constant. So it's a constant multiple. I could just take it outside the integral. So I will say this is equal to pi. Let it come outside the integral. 0 to infinity. Then what's going to be left? S cubed e to negative x dx. Now, if this is what we have, you could then say from what we've just done earlier that this is pi multiplied by everything here is just 3 factorial. Everything there is just 3 factorial. Or you could say it is the gamma of 4, but then it's then become 3 factorial from the previous video. Okay, so this becomes pi times 3 factorial, that's 3 times 2 times 1. So this will then become, what will it become? 6 pi. I believe you know why it's going to be factorial because I've explained this earlier on. Why it's going to be factorial. Gamma function, okay, the gamma of x plus 1 is equal to x factorial. So we did that in the previous video. Okay, the question number 3, which is the last for today. I don't want to use another part of the board to solve this. So this will just become 5 factorial. There's really no need for me to start stressing myself for this. That will just become 5 factorial. Because I have 5 here, so that's 5 factorial. So I would then say this is 5 times 4 times 3 times 2 times 1. So that's 120. So this is what I have. And that's just the answer to these very 3 equations. Now remember to hit the subscribe button, like this video, and share it across to your classmates. I'm going to see you in the next video.